Welcome back. Today we're going to be talking about active transport. So last time we talked about passive transport. We mentioned active, but only as much as to say it requires energy. Today we're going to be talking about exclusively active transport in a cell. So remember, cells need to take things in and get things out. They can do that by using one of two types of transport, passive transport or active transport. And we're going to be focusing on active transport today. So, cells may sometimes need to move molecules against the concentration gradient. So sometimes a cell is going to need something, and it may require, instead of going with the gradient from high to low, it might require going in the opposite direction and moving things from an area of low concentration to an area of high concentration. And this is going to be similar to trying to, like, if you're pumping up a bicycle tire, pumping up a tire that already has air in it. It's similar to that. There's more air in the tire, but you're trying to put more in there. And that's going to require the input of energy. So it's going to require ATP, energy, but it's also going to require a carrier protein. Before we get too far into this, I want to first give you guys my little trick for remembering active transport, passive transport, and high to low or low to high. So the way that I remember it, I have a pen here. If I want to get this pen from high to low, I don't have to put in any energy at all. I just let it go. High to low, it drops. That's passive, no energy. I don't have to put in any energy to get this pen from high to low. It just does it all on its own. However, if I want to get this pen from low to high, I'm going to have to put in some energy. So if I want to get it from low to high, I have to put in energy to get it to go up. So that's how you can remember active, passive, high to low, or low to high. So again, we're talking about active transport. We have to put in energy to get it from low to high. It doesn't just go up all on its own. So low to high. So last time we talked about carrier proteins just briefly. We're going to talk about them a bit more. So the way that carrier proteins work is they're going to bind to a substance on one side of their membrane and then release them on the other side. So this molecule binds here on this side, but it's going to be released out on the other side. So they are used to carry molecules against a concentration gradient. And that's going to require the input of energy. One of the most famous or most heard of type of carrier protein is going to be the one involved in the sodium-potassium pump. So an important example of an active transport protein is the sodium-potassium pump. And what this is going to do, it moves molecules of sodium and potassium in and out of a cell. It does this to regulate water. It also does it to help nerves fire and to make muscles contract. And the way it works is by pumping 3 sodium out, so 3 sodium out and 2 potassium inside of the cell. Both of these ions are being pumped against the gradient. So they're both being pumped against their gradient. And this balance or off balance of charges is going to cause the firing of nerves and lead to the muscle contractions. So that's very important in keeping our body functioning. So that is just active in general. So summary, small molecules move across the cell membrane all on their own. Simple diffusion is passive transport. moves from high to low through a protein is facilitated diffusion. Molecule moving from low to high with energy is going to be active transport. And there are two more types of active transport that we're going to talk about, and they're going to be called endocytosis and exocytosis. So what these are moving large molecules into and out of the cell using vesicles and vacuoles. So one, the movement of a substance into a cell using a vesicle is called endocytosis. Endo means moving something into the cell is called endocytosis. So the way this is going to work is, and I think this thing will present for you. So the way that endocytosis works is I have a molecule on the outside of the cell and it needs to go in. Is it going to do it? Guess it's not going to do it. Well, what will happen is the cell membrane will slowly start to cave in. The cell membrane will slowly start to cave in. It will bud off and create a vesicle inside. So if we look here, these were on the outside. The membrane will start to cave in. It will wrap around, and a vesicle is going to be made to bring that molecule in. When the opposite happens and a vesicle comes from the outside and moves toward the outside of the cell, that is going to be moving a substance out of the cell. And that is called exocytosis. So exo means out or exit. So endocytosis, moving something into the cell. Exocytosis, moving something out using a vesicle. So the cell membrane is actually going to create a little vesicle coming in or going out. So now we're going to fill out this summary table of all of the transport types. So I'm going to bring this up a little larger, that way we can fill it out. So the transport summary, we're going to go through all of this together. We'll do diffusion first. Diffusion is passive transport, so it requires no energy. It involves going from an area of high concentration to an area of low concentration. It does not require a protein. Things are going with the gradient, and there is no vesicle. So diffusion, passive transport, something going in the cell all alone with no help at all. Facilitated diffusion, anytime you see the word diffusion, it is passive. No energy is being used. It's going from high to low. This one does use a protein going with the gradient, but no use of vesicles. So facilitated diffusion is diffusion that is helped with the use of a protein. Osmosis. Remember, osmosis is water. It is passive, no energy, high to low, no protein, with the gradient, no vesicles. The only difference between osmosis and diffusion is osmosis is the diffusion of water. All right, so that's our passive section. All of those are passive. Now we're getting into our active section. So active transport is active. It requires energy. It goes from low to high. It does require a protein. It goes against the gradient and does not require vesicles. Endo and exocytosis, for the chart purpose, is going to be the same. The only difference is exocytosis is taking things out. Endocytosis is going to be bringing things in. But for the purpose of the chart, they're both the same. They're both active. Since they are active, they do require energy. Things are moving from low to high. These do not require proteins because the cell membrane is moving. It's going against the gradient. And these two do require the use of vesicles. Remember, things bud in or they bud out of the cell membrane using vesicles. So that is your transport summary. There's going to be some more practice on Canvas to finish up this unit.